So the problem we're going to look at now is how to invert a binary tree. I think this is a great problem to start warming up to how to manipulate and work with trees. So we're just going to jump right into it. So the first thing that I do whenever I get a problem is try to really understand the problem so I'm not solving for the wrong thing. So that's what we're going to start doing here. So the problem simply states to invert a binary tree. So I think there's two main points that's important to note here. The first thing is that we're given a binary tree. What that means is we can assume that each node has no more than 2 children. It could have 0, it could have 1, it could have 2, but it definitely cannot have more than 2. So I think since this is an inversion, that would make things a little easier given that we don't have to worry about odd numbers or anything more than 2. Second thing that we want to really figure out is what do they mean when they say invert a binary tree? So this would be helpful if we started looking at the examples. So we can see in the example input, we have a root node of 4. It has children 2 and 7. And in the output, we have 4, but the 2 and the 7s have been switched. And I think it's also interesting that the 7 has children 6 and 9, and the 6 and 9 follow the 7 when it was switched, but it was also switched. So it looks like right now I'm visualizing little subtrees that are being reversed in a mirror kind of way. Okay, cool. So now I think I have a pretty good understanding of what the problem is trying to ask me. And the next thing I like to do at this point is to create some of my own examples so I can say, oh, this is my input and this is my output. And that usually helps me solidify my understanding of the problem. And usually when I'm drawing out my own examples, I also get a better sense of how to break down the problem into some smaller subproblems so that I can formulate my solution better afterwards. So let's get started with drawing some of our examples and kind of thinking through how that would be processed. So the simplest example I can think of right now is if we just had a tree with one node. So if we had a tree with one node and we wanted to invert it, that would result in the same tree. Pretty simple. So now if we expand on this a little bit, we have a tree with 2 nodes. If we inverted this tree, the 1 would stay the same place as we did in the previous step, and 3 and the 2 would be switched. Alright, this is still pretty straightforward. Now let's do something a little more complicated where the tree has 3 levels. So say this is our tree with 3 levels, and we wanted to invert this tree. How do we go about doing that? Well, for the smaller subtree of just 1, 2, and 3, we had did it up here, so I'm going to copy that down here. And I'm going to try to follow the same pattern that we did up here with these smaller subtrees down here. So what I mean is, with this subtree of 2, 4, and 5, if we're following the same pattern that we had over here, it would become 2, 5, and 4. And the 3, 6, and 7 subtree, it would become 3, 7, and 6. So now we have these 2 subtrees, and I'm going to go ahead and append it here. Cool. So this was a great way that I thought of to break up this problem into smaller subproblems so that it becomes a little easier to visualize what's going on. So this is starting to seem like a recursive solution to me, since what we're basically doing is looking at this tree first and then looking at the smaller subtrees within it after we're done with the first inversion. So if I was to write down this into pseudocode, so draw out our tree again. So the main thing I'm doing is I'm looking at a node and I'm looking at its left child, and I'm setting that left child equal to the right child. And I'm doing the same thing for the right child. I'm setting the right child equal to the left child, basically switching them around. So let's see how that code would work if we just had this tree. So we have 1, 2, and 3, and then we call node.left equals node.right. And then our tree becomes 1, 3, 3. At this point, it seems like we've already lost our reference to the original 2 node here. So that's problematic. So I'm thinking we probably need to also create a temporary variable. And that way we can keep track of which node has been set, and we can keep a reference to it so that we are able to set the other node here. So what we want to do is probably something like a temporary node, temp node, and we're going to set that to the node.left. And that way we could keep track of a 2. So at this point, our temp node would be 2. And then we call node.left equals node.right, and this would be our tree. And then we would call node.right equals our temp node, the one that we had saved the reference to earlier. And at that point, we would have 1, 3, and 2. Okay, great. So now we've kind of mocked out how we would invert just one little subtree. And I think this would work pretty well if we were doing this recursively. So I have a pretty good idea of the approach I'm going to take. So I'm going to jump right into the coding here and see how that's going to work out. Alright, so we have inverted tree. Since this is a recursion, this is a recursive solution, I'm going to start off by thinking about what my base case would be. So if my root is null, I would probably also want to just return the root itself, or null. Otherwise, like we kind of mentioned before, here we're going to set the left equal to the right and the right equal to the left, but we also have to make sure that we keep a temporary reference to our left node so we don't lose that reference and not be able to set the right node to anything. So let's do temp left node. Always want to name your variables in an appropriate thing so that if we're trying to go back and debug things later, it'll be a little easier on ourselves. So temporary left node is going to equal to root.left. Then I'm going to set root.left equal to root.right. And we're going to set root.right equal to the temporary node we had just created. Okay, great. So now at this point, if we go back to our drawing, so if we start a new drawing to get a better sense of what we're trying to do here. So if this was our original tree, and we had our code so far, then our tree is now something like 1, 3, 2, and its children has followed it here. But what we want is for its children to also be flipped, like this. So it seems like we should call the same function that we have called earlier on these subtrees here in order to get this effect. So if we go back to our code, we could do recursion on the left subtree and on the right subtree. And in the end, we still want to return the original root node, so I'm going to return root. Alright, great. So now we have some code written out. I think a good thing to do next would be to verify and prove to ourselves that our code will indeed work. So we go here and we draw out our tree and we see what happens at each phase. So if we start at the 1, 2, and 3, our root is not yet null. Our temp node at this point is going to be, I'm going to shorthand it to temp ln, and that's temp left node. So our temporary left node right now is 2. Now our root.left is equal to root.right. So now we have 1, 3, 3. And then we set our root.right equal to our temporary left node. So now we have 1, 3, 2. And then we're going to invert the left and the right. So luckily for us, the left and the right has no children, so we are done. Eventually, what's going to happen is we're going to come down here, and these are implicitly null nodes. So we're not going to end up doing anything here. So at line 12, it's going to start returning, and that's when we finally get our original tree. Great, so I'm pretty convinced that this code will work. Let's actually run our code and see how that turns out. Accepted, awesome. So that was a very basic approach on how we can invert a tree with a recursive solution.